Hi, my name is Buck Haygood, and today I'm going to show you the importance of data mining in the retail industry. First, let's begin with a quick overview of what data mining is. Simply put, data mining is the process of discovering patterns from the analysis of data. Further, new technologies and practices within data mining allow users to examine data more effectively by categorizing it, summarizing it, or even isolating certain aspects of it. The discovered patterns can then be used to create new and more effective processes relative to the respective situation. For instance, it can be used for profiling within detective work, advertising strategies in the marketing world, fraud detection in the banking industry, and, as I will go into detail with, data mining is extremely beneficial to cutting costs and increasing revenue within the retail industry. Next, I want to go through the thought process of data mining as a whole, applying it to the retail industry along the way. Here's a flowchart of the steps taken. As with numerous processes, we must first define the problem. Since the retail industry is a business, our goal is to maximize profits. Consequently, our problem is figuring out how to do so. Many people are quick to jump to the simple conclusion of sell more. However, it is much more intricate than that. Which goods have the highest profit margins? Which goods cost the least? What is the shelf life of certain goods? Questions can be even more specific than that. Which goods sell best at night? Which goods usually sell in pairs? In triplets? Which goods sell best in the spring? The questions are endless. The next step in the process is preparing data. Preparing data may seem bland, however, it is arguably the most vital step in the data mining process. For, without data, there is nothing to examine. Retailers collect data from every sale, however, it must be properly managed to help maximize profits. For, it is from the just mentioned questions that the desired data is derived. As stated, in the retail industry, data is collected upon sale, or lack thereof. So let's consider a hypothetical customer named Daniel in his trip to Walmart. Imagine Daniel buys a king-size Mr. Goodbar, the newest edition of Madden, and a pack of batteries. As simple a purchase as this may seem, tons of data can be extracted and prepared from it. For instance, to narrow the scope, let's deal with 5 possible entries: price, time of sale, contribution margin, contribution ratio, and associated sales. These are all obviously very important, and retailers can take shortcuts to simplify the database. For example, time of sale can be recorded in Army time to eliminate the need for AM and PM. An item like contribution ratio can be calculated from 2 existing categories, removing the need for another entry. Lastly, each item can be given a specific item ID number to reduce the length of entries. This is only a snippet of the massive amounts of data that can be stored regarding a single transaction. To help manage this vast amount of information, many companies use a database system called Oracle. This is similar to SQL, which we are all familiar with thanks to class. Now that we have some data to work with in the form of Daniel's trip, let's look at the next step in the process, exploring data. First, look at the time of sale, 16:07 or 4:07 p.m. This is roughly an hour after most elementary and high schools are let out. Perhaps there is a correspondence there. Managers could check the average time of sale for these products and perhaps do a corresponding promotion. Next, look at the associated sales. Does the sale of these 3 products usually occur at the same time? Herein lies some ambiguity that can be cleared up by data mining, for association does not always equal causation. Data mining technology would allow you to cross-check associated sales, giving you an output of percentages. For example, data mining could return to you the percentage of times that batteries are bought when a video game is bought. Another interesting exploration of Daniel's trip involves an accounting term. Within the previous table is both contribution margin, CM, and contribution ratio, CR. CM is the difference between the cost of the product and the selling price. Basically, it is the profit of the item. CR, however, shows how much a product sells for relative to the cost of the item. In this example, the king-size Mr. Goodbar has a lower CM but a higher CR. While what to do with such knowledge lies in the realm of a manager or accountant, it is made available to us thanks to data mining. Data mining can show the highest and lowest CMs and CRs for store managers, and they can change the quantity of each item purchased if need be. The last steps in the process, conceptually speaking, are fairly vague, so I will quickly explain them before moving on to a specific aspect of data mining in the retail industry. The main point to get across here is that from the preparation and exploration of data mining, one must create a model that attempts to solve the initially stated problem. Further, this process is never ending. Models can change every year, every month, even every day. For the retail world, these models indicate what to do with certain products in order to maximize overall profits. Where to put them in the store, when to sell them, how much to sell them for, how many to purchase, the list is a long one. Market basket analysis is a process made available to us by data mining and is key in the retail industry. Market basket analysis is formed from the idea that if you buy one product, you are more or less likely to buy other products. The classic example is beer and diapers, as many husbands find themselves picking up the week's supply of diapers while on their Thursday and Saturday beer runs. See, the group of items a customer purchases is called an item set, and market basket analysis attempts to find relationships between items within item sets. These relationships follow a form similar to commands in MySQL. If product 1, beer, then product 2, diapers. From this statement results a probability that is referred to as the confidence of the relationship. So if the confidence of purchasing product 2 after purchasing product 1 is particularly high, then the items are likely to be placed near each other. Herein lies the importance of market basket analysis. The highly correlated products are placed closer together than others. This process is called point of sale, and it helps determine shelf space allocation, store layout, and product location. So now to put this point of sale and market basket analysis to the test, we'll check my refrigerator. If you look around, it's pretty barren, but 2 or 3 big things. I have way too much sliced cheese, and there's a bunch of ham, and this is actually a container half full of milk. So keep that in mind, and we'll see what the Harris Teeter has for it. Okay, so as you'll see, here we have the ham. And if I was to be making my way out of the store, I would have to pass the milk here. And it would be pretty hard to miss the cheese. Well, I hope this has been a good tutorial of data mining and its benefits in the retail world. Daniel, and all of us really, are subject to its use every time we walk through the automatic doors of any superstore. So get out there and see what data mining has done.